here which looks like this. And as you see this, this is where you choose your operating system. If you are using, so you can see that's the EV3, the Lego Mindstorm EV3 is only compatible with Windows 7, Windows 8.1 and Windows 10. Okay, so it is not compatible with other versions of Windows. Alright, so then you scroll down and all you have to do is to then click on download. You do the same thing. With VRT, and so all you have to do is just to click on the VRT link, and this is what the VRT screen looks like. You then choose your operating system between Windows and Mac. Okay, so so I believe most of us are using Windows, so just click on this icon and then the download will start. Right, and so now that you have your software, so you then now move and open up both of your software. Okay, and so as I'm opening and starting a new project, please also follow on my steps. Alright, so to start a new project on EV3, on the Lego Mindstorm EV3, the first thing that you'll see once you have opened up is this announcement here. Okay, so let's close that. And of course, you're then taken to the lobby of the EV3. Once you're in the lobby, you then click on File. You then click on New Project. Once you click New Project, you then click Program. And you then click Open on this side, the Open button here. So as you can see, once I have clicked Open, now my new EV3 project will then start. Alright, so now I have the new EV3 here. As you can see, I have a new EV3 project, and I'm taken to the programming canvas, and I can see the Start button there. Okay, so this means that I can now start adding blocks into the programming canvas in order to make the robots to do anything that I want. Alright, so now let's come to VRT. Okay, so on VRT, you can close the menu tips, and so your VRT will then look like this. At the top there, you'll have your menu. And on the menu, you then click on New Project. And then, okay, so for now, let's just open up the sandbox. Okay, so let's click on the sandbox. And then you give your project a name. And then you click OK. Right, once you have clicked OK there, VRT will then initialize a new mat or a new simulation environment, where you will now see what your robot can do depending on the code that you have added on your EV3. Alright, so once the mat has fully loaded, you will then be able to connect the virtual robotics toolkit and connect it to the EV3. Okay, and so you'll see that once the VRT project is loaded here, you will then, on your Lego Mindstorm EV3 now, you then scroll down on this part at the bottom right corner. This is what we call the brick view. Okay. So this is what we call the brick view. Once a mat is loaded on VRT, you can see now there is a robot or a brick available, and all you have to do to connect your EV3 to the VRT is to click on the Wi-Fi tick box. Right, so let's click on the Wi-Fi tick box, and you can see it now says connecting. Right, and so Once it says, okay, so once that message shows, you can just close it. And then you can now start programming your robot. Okay, so let's now start by talking about the two types of move blocks that we learnt about in term 3 as we began in term 3. Okay, so for this term, everything that we're going to do, the assignment that we're going to do is based on the move tank block and the large motor block. So those are the two blocks that we will be learning about them today. Right, so before we do that, let's now see how we can save our EV3 project. Okay, so to save your EV3 project, you go there to the Start menu. As you can see there, it says File. You click on it. You click on File. Once you have clicked on File, you'll then see the menu there which says Save Project As. Okay, so you click on Save Project As, and the pop-up window will then appear on your screen. On the pop-up window, you'll be able to choose a folder where you are going to save your project. Okay, so I can just go to Documents, and then if I want to find my all of my documents easy, I can just go to Documents, and once I've gone to Documents, maybe I can then start a new folder. Okay, so let me just right click there. I can then just click here and start a new folder where I'm going to save all of my EV3 projects, and I can give it a name, and I can say EV3 project. Okay, so I can say EV3, and then I can say project, so I can just say EV3, and then I can open it, and then I can now say okay. Once I've opened it, I can now give my file a name once I've clicked on it. So let's just say this is my first program. Okay, so when you are naming your EV3 program, avoid using numbers. Okay, so only use words, and it's better if you just use a single word to save your project. And then you click on the folder, then you click open, and then you click save. Okay, so now the project is now saved. So if I can go to my file explorer, so let's try and go to the file explorer. If I click on my file explorer now, and I go to documents, okay, so let's see if it takes us to the documents. Okay, so let's open up the file explorer, and once I've opened up my file explorer, if I now go to documents, and then I can now go to where I save and say EV3, the folder which I created, and so you can see that there's my first program inside the folder. Alright, and so that is now how you save the project. Alright, and so now let's begin then now adding blocks into the programming canvas. Alright, so let's start maybe with the 3 different types of terms that we learned about this term. Okay, so we have, remember we have the spin turn, we have the pivot turn, and we have the smooth turn. Right, so let's start with the pivot turn. In order for us to achieve a pivot turn, we can go here. So these different colors are called the block palettes. Each of these, you'll then use each of these blocks to program and code your robot to do a specific task or a specific action. The first one there is called the action palette, meaning we use the blocks in here to move the robot around or to cause the robot to act or the program to act in a particular way. You will see other block palettes such as the flow control palette, where we find the wait block, the start button, and some looping button which controls how our program will run. Okay, so let's go back to the action palette, and we now add a move tank block. Okay, so the move tank block is the fourth one there, and I can now drag it to the programming canvas. Okay, so once you drag it to the programming canvas, okay, this is how a default move tank block looks like. And so we say that we want to do a pivot turn using the move tank block, which is currently on the programming canvas. Remember, to do a pivot turn, you need to have the power of one of the wheels at 0. Okay, so remember, the move tank block controls each large motor individually. And so you'll have the power of one wheel here and the power of another wheel here. So let's make the power of one of the wheels to be 0 in order for us to achieve a pivot turn. So if we say 0 and we press enter, and then now we need to also specify how long or how far do we want our robot to turn. Okay, so now we specify the number of rotations. Okay, so we can just say maybe 7 rotations. Okay, so if we say 7 rotations, and once I've added my first block there, I can now click on the play button to see what my program does. Okay, so if I press there, so now you can see, now my robot is doing a pivot turn. Okay, so a pivot turn is basically called a pivot turn because one of the wheels is not moving and the robot then circulates or turns around one of the wheels. Okay, right, we can still do a pivot turn using a large motor block. Okay, so we can just delete this block and we can then add now a large motor block. Right, here's a large motor block. Now we can now go here on our VRT and show that you always reset your mat and return the robot to the starting position before you simulate new changes on your program. Right, and so now that you have the large motor block, right, so using now, how now are we going to achieve a pivot turn using a large motor block? The first thing, of course, that we must know about the large motor block is that when we use it, it is the same as though we are using the move tank block and the power of the other wheel is 0. So this means that on the block that we have added onto the programming canvas, we can now specify the power and the number of rotation for the moving wheel. Okay, so if I say now 7 rotations there, and I press enter, and then I simulate, I press play to simulate, you will then see that now my robot is doing exactly the same thing as it was doing when I was using the move tank block and I had set the power of the large motor in port C at 0. Alright, now remember, whenever you now start your program, you then need to have a pseudocode. Okay, so for a pseudocode, these are the 3 ways which you can now do your pseudocode. So take for example this program. This program here is making the robot to spin around, to turn around one wheel for 7 rotations. And so if I want to specify that on my pseudocode, I can then start by using a comment. A comment is found here on the toolbar, and I click on the comment, and so you see the comment now appears, and I can drag it to be above the block to explain what the block is doing. And then I can say turning, and then I can say since the number of rotations here is positive, it means the robot is turning clockwise. So I can say turning clockwise for 7 rotations. And so I have now done my pseudocode for this program. Okay, and then another way that I can do my pseudocode, so let's delete the comment there. The second way that you can use the pseudocode is to come to the advanced block palette here. So if you click on advanced, you'll then see the last block on advanced there is what we call the comment block. So the comment block, even though the comment block, when you edit, it looks as though it's part of the program, it will not have any effect on what your robot does. And so once you have that block, you can then double click inside the white space, and then you can now start typing turning clockwise for 7 rotations. Okay, so once I have that, and then I can then do it like this. And so you are going to do a similar thing on your own assignment when you have to do the pivot turn. Alright, so let's now speak about the second type of turn that we learned about this term. Okay, so remember the second type of turn that we learned about is called the spin turn. Okay, so for the spin turn, remember that for the spin turn, what you need to have, you need to then have the power of one of the wheels to be a negative value and the power of the other wheel to be a positive value. So let's now go to the action palette and take our move tank block and add it to the programming canvas. And then remember, when you make changes to your program, remember to stop simulating and reset your mat. Right, and so we said that the power of one wheel must be negative. We have the wheel here, we have the power of the wheel at port B and the power of the other wheel at port C. So if I make the power, I can make then the power of the large motor in port C and make it a negative value, and I can say negative 50. And then once I've specified the power, I then specify the number of rotations in which I want my robot to turn. And then I can then just say maybe 10 rotations and press enter. And then I can now click play and simulate and see what is happening to my robot. Alright, so now you see that the robot is now spinning around the center of the robot. In other words, the spin turn only makes the robot to spin. Okay, so the robot does not necessarily change its position significantly when it's doing the spin turn. Alright, and then I can still make the spin turn. If I want to make the spin turn to go in reverse, I can change the number of rotations and make it a negative number and say negative 10 and press enter and then start simulating. And then you'll now see the robot is now spinning the other way around. Okay, so this is now what we call the spin turn. And then we have the last type of turn that we learned about. And now, so let's delete this block. And now this type of turn is now called the smooth turn. So the smooth turn, so let's now add our move turn block. And then once we've added our move turn block, in order for us to achieve a smooth turn, all we have to do is to make sure that the power of one of the wheels is less than the power of the other wheel. So if we can set the power of the wheel in port B, let's set it maybe to 40, and then we can set the power of the second wheel maybe to 10 units. And then we need to specify the number of rotations that we want our robot to turn. Okay, and so we can maybe say 7 rotations and then press enter. And so when I do that and then I press simulate, I start the simulation, you will then now see the robot doing a smooth turn. As you can see, both of the wheels are moving. It's only that one wheel is moving at a faster speed and the other wheel is moving at a lower speed, which causes then the robot